This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today.
Hello and welcome back to Slooh.com. My name's Will Gator, and tonight we're celebrating the opposition of the gas giant, the ice giant Neptune. What does that mean? Well, tonight the planet is opposite, directly opposite the sun in the night sky, and it's a fantastic time to look at the planet because it is visible all night long as it sits there in the sky. Now, unfortunately, we can't see this planet with the naked eye. It's not like those beautiful sparkling planets, things like Venus, Jupiter and Saturn, which we can admire just with the naked eye of a beautiful horizon. We have to use binoculars or a telescope to see it. And tonight, of course, here on Slooh.com, we're going to be using our powerful telescopes located tonight in the Canary Islands, the ones we're using. So as this zooms into La Palma and Tenerife, and Lanzarote and all the Canary Islands there, we'll see as we come into the top, we see our Slooh Observatory there on the hillside. And we've got fantastic conditions tonight. We already know that the skies are clear over Mount Teide in the Canary Islands, and we've got a beautiful view of the heavens tonight. Now, the moon is up, so if we can go to our live all-sky image, you'll see that bright object there, that's the moon in the sky. But off to the right of it, you can see that that's where Neptune is, and actually you can see in the left-hand corner there, Slooh's telescopes, the domes are open, and we are, as we speak, capturing images to bring you live pictures of Neptune tonight. Now, of course, as I said, opposition is a great time to look at Neptune and observe Neptune, but it's also a good time to sort of take stock, and I think in some ways it's a good time to reflect on what we know about this enigmatic planet and also what we don't know, the sort of mysteries of the planet, because in many ways there's a lot that we want to find out about Neptune. Neptune is a planet that we've visited only really very briefly, and we're going to be talking lots in more detail about some of its other more mysterious side, like some of its moons. The moon Triton, for example, its largest moon. That's a very interesting world, and I'm going to be talking later with Slooh astronomer Bob Berman about that. But before we do that, I want to show you these live pictures that we've been getting in the last few minutes from our telescopes. There is the live picture from the Canary Islands, and that is with our half-meter T1 telescope. Absolutely extraordinary. The planet is the bright object right in the center. And do you remember I said about Triton? Well, look just below it in the 6 o'clock position. That little dot of light, that is the moon. Now, we're going to be talking a lot more about that moon very shortly, but to me, this is one of the most extraordinary things about this planet, is that that light that we're seeing there left Neptune 4 hours ago. So you're looking at live pictures, but such is the vast distance. Tonight, Neptune is about 4.3 billion kilometers away. And such that vast distance that it's taken 4 hours for that light to get here. And I think that's an incredible thing. Not just that this is a particularly intriguing world, but this is one that is really right on the outskirts of the solar system. So we've got lots coming up in the next half an hour or so. We're going to be talking lots in detail about some of those strange aspects of Neptune and some of the interesting things about it. But we've also got a lot coming up here on Slooh over the next week, and that's what we want to talk to you about and tell you about just briefly about some of the shows that are coming up so you don't miss them, especially for members and also some really cool live shows coming up. So one of the things we've been doing is we've had a nightlight show that's basically, we're having a brand new show every other night at 10 p.m. and it's called Nightlight, and we feature basically 10 minutes of live views of celestial objects with music and interesting facts and things about that. Then, of course, coming up later in the week, on the 12th of September, we have a partial solar eclipse, and that's going to be a fantastic event. We're basically going to be watching the partial solar eclipse live on the night of the September the 12th and into the early morning of the 13th. And of course, this particular eclipse, this partial solar eclipse, is only visible from South Africa, but thankfully we've got feed partners located there that are going to be providing us with live video of that event. Then we're also going to be doing something a little bit different for Slooh. Rather than looking at a celestial object, we're going to be looking at a man-made object in space. And that's when we're going to be looking at the ISS, the International Space Station. So we're teaming up with NASA to celebrate really the halfway point of astronaut Scott Kelly's year in space. An exciting show where we're going to have not only live views of the International Space Station from Earth, but also live views of the Earth from the International Space Station. And one of the things I'm really excited about is that we're going to have a special interview with astronaut Katie Coleman. And that's going to be great to get her perspective of what it's like living in orbit above the Earth. But that's not all we've got. Later on, we're going to have 24 hours of sunlight. That's on the September the 23rd. That's a Wednesday. And that's basically where we're going to be celebrating the day of the autumnal equinox. So we're going to be broadcasting live views for a full 24 hours. And so we're going to be discussing not just the equinox, but also its importance in human culture throughout the ages. And really, the month ends as it begins with a fantastic selection of celestial sights. And perhaps the one to really top it all off is the lunar eclipse on the 28th of September. And we're going to be having a mega harvest moon eclipse show where we're going to be broadcasting the entire eclipse. So that's not to be missed. I mean, lunar eclipses are a beautiful, graceful affair, and that's something that's going to be really, really special. So I hope you can join us for that later at the month, towards the end of the month. But let's go back to these live images now. This beautiful live picture that's coming down from our half-meter telescope in the Canary Islands. And I want to bring in now a good friend of Slooh, Slooh's astronomer, Bob Berman, who is the author of Zoom, How Everything Moves. Bob, we're getting these beautiful live views in that sort of little dot of light there at the outer reaches of the solar system. I think Neptune, in some ways, as a planet, it's sort of overlooked, isn't it? I think, anyway.
Well, sure, because it's the only planet that we can't see with the naked eye. Even Uranus is faintly visible once in a while. I've seen it naked eye. You really need to be out on the boonies, out in the countryside to be able to see it in rural, unpolluted regions. But Neptune, no question about it, the most distant planet now that Pluto's been demoted, and so much more. There's so much going on with it. Combination of science and mystery. We really could spend hours talking about it. We don't have hours, but we'll explore it to the extent that we can tonight with these live images of Neptune. You can see it's colored too. It's bluish color. Even the color is a little bit of a mystery. I mean, we know that methane, which is present, absorbs red light and lets the blue and the green reflect away, but that doesn't still explain why it's so deeply blue. So even the way it looks is not completely understood.
And I guess a part of that, we should go back to actually where it is in the solar system. I've said earlier that tonight it's like 4.3 billion kilometers away, but this is a region that really is in the outer peripheries of the sort of planets, isn't it?
Oh, certainly, absolutely. It's against the faint stars of Aquarius, which resembles a man pouring water to the same extent that you and I resemble giraffes. You can't really make a figure out of it, but that's where it is, and it lurks
boy, all the way out there, as you said, 19 times the Earth-Sun distance, or 19 astronomical units. Look at this interesting image that you've put up showing Pluto going around the sun, and it almost looks, if you didn't pay close attention, as if the orbit of Pluto crosses that of Neptune. But in truth, they are so tilted, the orbit of Pluto is, that they never meet. In fact, they have an interesting resonance where Neptune makes 3 trips around the sun, has a 165-year orbit, in exactly to the second the same amount of time that Pluto makes 2 trips around the sun. Pluto is just under 248 years. Multiply 247 point something times 2, and you'll get the same thing as Neptune's orbit times 3. So they are linked in an odd way that keeps them far apart. In fact, Will, as you probably know, you look at that, Pluto looks like it's the planet right outside of Neptune, but it actually comes closer to Uranus than it can ever come to Neptune. So strange things going on out there that we're exploring tonight.
It's a very strange part of the solar system, as you say, and I wondered if we could go back to really the very beginning. When did we actually discover Neptune?
Well, it was the first and only planet discovered, well, as long as you don't count Pluto, with our minds rather than by luck. On March 13th, 1781, William Herschel found Uranus just by plain dumb luck. But Neptune, different story. Uranus wasn't moving quite the way it should. And so 2 astronomers, John Couch Adams in Britain, and independently Urbain Le Verrier, calculated what must be tugging on Uranus to make it move so strangely. And Le Verrier in particular tried to get someone to point a telescope at that spot. Nobody was interested. Nobody. And so he finally got somebody named Gall, G-A-L-L-E, at the Berlin Observatory to aim a little 9-inch telescope in that direction. And that was on September 23rd, 1846. And within 1 hour of that telescope pointing there, within 1 hour, bingo, there was Neptune right at the correct spot. So good for him and good for Adams, both of them, the Frenchman and the Britisher. They both succeeded just using math precisely. And Le Verrier, unfortunately, started to get obnoxious about it. He wanted the planet named Le Verrier. And even his fellow Frenchmen said, no way, that's not going to happen. And fortunately, cooler heads prevailed. And the tradition of naming planets for Roman deities, Roman gods, prevailed. And it was named for the god of the sea, Neptune. Although Le Verrier is still honored, his name is on the Eiffel Tower. There's something like 72, I forgot exactly, 72, 74 French scientists whose names are inscribed on that first balcony on the Eiffel Tower. And there's Le Verrier's name, the 4th name from the left on the northeast part of the tower. It's crazy that I remember these things, but there he is. So even though we don't think about Le Verrier very much, there's his contribution as the discoverer of this this object. 165-year orbit, so slow moving, creeping against these very faint background stars.
We've got this lovely picture taken by our Slooh observatories, and that's actually a Slooh member, Keith Smith, who's taken this beautiful picture. And you can see Triton, its largest moon, there so clearly. And actually, what the thing I think is most surprising about Triton is actually it was discovered right after the discovery of Neptune itself, wasn't it?
Yes, just 17 days later. And this was really weird. And that was William Lassell, a British fellow who discovered it. And now things get strange. If we want strange, we've got strange with this, because number one, Lassell did not suggest a name for Triton, even though it's an enormous moon. These days, of course, the discoverer, there'll probably be a competition for what to name it. But everyone started calling it Neptune's moon because there was only one. And we're talking about 1846. October is when Triton was found. Finally, in 1880 or so, we're talking about 30-something years later, Camille Flammarion, a famous French astronomer, said, well, maybe we could name it, give it a name. Let's call it Triton, after that three-pronged pointy staff held by the god of the sea, it still didn't catch on. It wasn't until the 1930s that people started calling it Triton. But what's strange about it is that it orbits backwards. It's the only major moon in the solar system that moves in a retrograde fashion. See, we have a one-way solar system. Of course, all the planets go around the sun in one direction, counterclockwise if you're north of the solar system. And the sun rotates in that direction, Earth rotates in that direction, all the major moons spin around their planets, revolve around the planet in that same direction. Not this one, it's backwards. So we'd say, well, it must be captured. It must have been like a passing object that Neptune snagged gravitationally. But what's wrong with that is that it has a perfectly circular orbit. Very rare in the solar system. Nearly everything moves in ellipses. Earth moves in an ellipse around the sun. Our moon moves around us in an ellipse, like a squashed circle. But this is not only a circle, it's a perfect circle. And as you're a professional astronomer, Will, so you know that we measure these things by dividing the major axis, the longest axis of the ellipse, by the distance between its foci or focal points. And you're going to get a number between 0, which is a perfect circle, and 1, which is the longest stretched out squash ellipse you can have. Well, Venus, which is the most circular of all the planets, has a eccentricity of 0.007. That's impressive, isn't it? But this one, Triton, its eccentricity is 0.00000. And then the next
incredibly round orbit. And I think what's amazing is that we really got our very first close-up views of this system of Neptune in the 1980s with Voyager. And I think we've got some of the beautiful pictures that the NASA Voyager 2 spacecraft returned, and they show this extraordinary sort of blue color that you were talking about earlier. I wonder if we could put some of those on screen just to get a flavor of what this world looks like up close. And of course,
yes, quite a day.
Clouds.
It was August 24th, 1989, that I'll never forget it, when Voyager just whizzed past, taking a picture of this and of Triton itself. And until then, of course, we had no idea. Triton proved to be the coldest object in the solar system, and still is. And here's Neptune looking gorgeous. Its true color is not quite as deep and saturated or blue as this, but it's still blue enough. So what's going on with Triton? If it were a captured object, which it had to have been, otherwise how would it have a backwards revolution around its planet? How do you get such a perfectly circular orbit? So here is a really deep mystery as it orbits at every 5 point, I think it's 876. You know, these numbers are so easy to remember, 876. 5.876 days, almost 6 days. So that's pretty darn fast, isn't it? I mean, our moon takes a month to go around us. Well, here's less than a week.
We're going to be talking a lot more about Triton very shortly, but I want to go now to a very quick commercial break. We'll be back in 30 seconds, where we're going to be talking in a lot more detail about this incredible enigmatic moon and also some of those weird features that you can see in that picture. And of course, we'll get more of those lovely live images from our telescopes in the Canary Islands. So see you in 30 seconds. Well, welcome back to our live coverage here of Neptune at Opposition on Slooh.com, a special show for our members in the clubhouse. And on screen at the moment, you can see a beautiful image taken by NASA's Voyager 2 spacecraft of the moon Triton, the largest moon of the planet Neptune. In the top left of your screen, you can see our live images of Neptune from our telescopes in the Canary Islands. And Bob, we were talking earlier about Triton and some of its mysteries, and you used the word captured, and that kind of alludes to one of the theories about why Triton is so unusual in terms of being a moon of Neptune, doesn't it?
Yes, yes. Moons that started off with the planet are going to be born together. They're going to participate in the same one-way rotation and revolution around the planet. But to go backwards means it had to come in from a different angle in space. But then how do you end up with a perfect circle? How? How? Nobody can figure it out. And that's just the beginning, because Triton, which is great because we're looking at this live. Look at that here tonight, seeing live views of Neptune and Triton. And we thought it was the only moon. And then in 1949, Nereid was found, a little tiny thing. And darn it, if that's not weird also, because it has the opposite of a circular orbit. This one comes 7 times closer to Neptune on some occasions than on others. Imagine if our moon got 7 times larger sometimes than before and became just gigantic in the sky, and then went off in the distance and then came back again. That's what Nereid does. And then the Hubble Space Telescope found a bunch of more moons, and they're weird too. 2 of them are 30 million miles from Neptune that we're looking at live here. 30 million miles? You've got to be kidding me. That's farther than Venus is from Earth. How do you even gravitationally hold on to moons that are so far away? Those are the farthest away satellites from any planet in the known universe. So everything about this Neptune system, cries out for either further exploration or for some kind of exploration. It's a fascinating world. So it's people who are tuning in and seeing Neptune and seeing its bluish color here live and are going, oh, that's kind of cool. The more you look, the more cool it gets, the more amazing it gets.
Yeah, and I think if we can go back to that Voyager 2 image of Triton, there was a little feature, or actually several features, along the bottom of the image. There's little black streaks, and I think they are perhaps the most exciting thing about this moon, because as I understand it, some theories suggest that these could be signs of cryovolcanism. Is that right, Bob?
That's right. That it's so cold out there that the only thing you're going to get is volcanoes spewing water, or even little ice crystals. And look at this fascinating satellite. And the measurements made at that time, as I said, show it's the coldest place in the solar system, 19 times farther away from the sun than we are. So it's a great place to explore here on this day, August 31st. We're looking at its very closest approach to Earth of the year. And man, look at these live views. It's so cool.
It is, and you were saying about missions to explore there. I read just earlier in the week, actually, that NASA have already put out a call saying to scientists that we want your ideas for how to basically explore both Uranus, the other ice giant, and Neptune. And I love to think that we would get a sort of Cassini-style survey of these planets, because we haven't orbited them before, have we? We've literally had these brief, fleeting flypasts.
That's right. There are only 2 planets that we've never orbited, and that's Uranus and Neptune. Both are huge. Both are about 32,000 miles in diameter. I know where you live, you like to use kilometers, as does the rest of the Earth, scientifically. Here in America, I'll represent our U.S. Oddball population in that we're still thinking in miles, all of us. But 32,000 miles in diameter, that's 4 times the size of Earth. So these are not minor items out here. These are big, major objects. Neptune is a solid planet. When we talk about demoting Pluto, Neptune has the roundest orbit, except for Venus, of any of the orbits in the solar system, which shows it really belongs with the solar system. Uranus has the orbit most on the plane of the solar system. So if you extend the Earth-Sun plane in less than a degree from that, only 46 arc seconds from that exact flat plane, there is Uranus. So these are really planets that are part of the scene, even if they're very unterrestrial, un-Earth-like.
And do we know roughly how they formed? I mean, we look at the inner solar system, we see these little rocky planets, but out there at the edge of the solar system, we have these huge gas giants. Do we know how they may have sort of came to be all the way out there?
Yeah, there's evidence, at least mathematical evidence, that they migrated, that they weren't always where they are now, but they've migrated to their present positions. As to being gas giants, that makes some sense because here in the inner solar system, we've got such a fierce solar wind and the temperatures are so high that if the planets here started out with a lot of hydrogen and helium, they would have escaped. The temperatures would have allowed them to be almost blown off, leaving just rocky cores. In a way, perhaps we could think of Mercury, Venus, and Earth and Mars as maybe the rocky cores of what could have been larger, more gassy objects to begin with. But that kind of gas is not going to stick around with the temperatures that we have. But once you get to Jupiter and beyond, then you're getting to giant, you can call them ice giants, ice balls or gas balls, because that's what they are: hydrogen, helium, and then some smelly stuff, methane, which is natural gas, ammonia. So if you wanted to land on it, if you had a spacecraft and you descended lower and lower and lower, you'd never get to a surface. There'd be no place to stand. You'd get nice and clean from all that ammonia. It'd be like sending something out to the dry cleaners. Your spacesuit would be sparkly clean, but you wouldn't be able to get out of the rocket and just stand there and plant a flag or whatever it is you had in mind to do out there. So they're very alien bodies. That's one of the reasons that maybe nobody's really thinking of, like, what can we do with them, because there's no romance in just being kind of sucked into denser and denser slushy materials until you vanish below the surface. That's what we've got here. At least it's easy to pronounce, Neptune, unlike Uranus that everybody mispronounces.
It's funny, isn't it, actually? You think that maybe we want to visit all these gas giants, but actually it turns out that really the moons of these planets seem to be the more interesting places in many ways. I think you think to Enceladus around Saturn, you've got Titan, Europa around Jupiter. I get this sense that actually the future of our exploration is not necessarily with those gas giants, but some of their moons around them. What's your opinion?
Yeah, you're so right. You're so right, without a doubt. Because first of all, you've got water, and water is not only is it the most common compound in the cosmos, but it's what we're made of. It's what life revolves around. It's what our brains are largely made of. So of course, it's water seeking water. Our brains are curious about something that's essentially composed of the same thing that our minds are based around. So these are the places, Will, that you mentioned, all of those, Enceladus and Europa, that have oceans, warm saltwater oceans. And as you brought up earlier, it's possible that Triton also has water below the surface. As cold as it is, there could be some layer for that. And anytime you're talking about water, you're talking about the possibility of life. So as strange as it is, we may actually come to eventually find life out there, not on these gas giants, but on their moons, which we're seeing live. Look at that, so clear. There is Triton, discovered 17 days after Neptune itself was discovered on September 23rd, 1846. 17 days later, there was Triton found, thought to be the only moon on Neptune until the late 1940s.
And Neptune actually has a ring system, doesn't it? We can't see it in this image; it's incredibly faint, but it was discovered quite late on in the history of the planet.
Yes, and for good reason, because it's so skimpy. We almost should have different words. Sometimes English, with its richness, doesn't have enough words. We have only one word: earthquake, maybe tremor, we might say, for a phenomenon that you might not even be able to detect or feel. And for the same phenomenon, earthquake, something that would destroy cities and kill 250,000 people at a time. Single word, earthquake. Same thing, similarly, we have just this one word for this thing that we're seeing out here. We have the same thing with moons. Here's a giant moon, Triton, one of the 5 large moons of the solar system, and Triton also has Nereid, a little piece of garbage that's not even large enough to be round. So a lot going on.
Mm. Yeah, it's one of those things that I think the more we explore these sort of weird things, we start to kind of understand a little bit more about the sort of solar system in context, isn't it? Because I think it's true for, when we've been looking out into the galaxy, we see exoplanets, and when we've discovered things like hot Jupiters, these huge gaseous worlds orbiting close to their star, and then you suddenly start to look around and see that actually our solar system, is quite unusual in itself in its construct, right?
Oh, absolutely. And as we look at the live view of Triton, the moon of Neptune, and Neptune itself, we see faintly the blue color. Quite right. We're talking about exoplanets that we will not get to, even if we decided to launch tomorrow. It would be thousands of years before our fastest rockets could get to the nearest exoplanets. And yet, here in our own solar system, the satellites, such as Triton, and others in our solar systems are just brimming with potential. We don't know what's there. But anytime we have oceans, especially warm saltwater oceans, especially oceans that have been bombarded with comets that have delivered amino acids, ample amino acids. In fact, every amino acid known has been penetrated, delivered to these objects, to these saltwater oceans for billions of years. So if life could start on Earth, it certainly could have originated in these places as well. So exoplanets, sure, but hey, we may not have to look beyond our own solar system. We may find it right in what we're looking at live right now, in that intriguing moon Triton that orbits backwards. What's going on there?
That's a lovely thought, actually, and I often think when I'm looking at these live pictures is how different history would have been if we had things like Slooh. I mean, we would never have had that slow sort of take up to discover Neptune. If Slooh astronomers were around today, I'm sure that there would be an immediate follow up and discovery of the planet. So it's amazing what we can do and see these live pictures coming as we speak from the Canary Islands.
Yeah, quite so. And why did it even take that long? The invention of the telescope, Galileo was already using it in January of 1610. Why did it take until 1781, almost 2 centuries, before Uranus was seen through a telescope by William Herschel? It's positively brilliant through any telescope. Our Slooh members who look at Uranus, you almost need sunglasses to see it. All right, I'm exaggerating a little bit, but look at Neptune. This is 8th magnitude. Now that means it's within view of ordinary binoculars. And if you looked at the right spot in Aquarius, you could actually see it moving from night to night, very slowly, but it's moving the wrong way. These nights it's moving in retrograde motion because Earth is passing it, just like a truck on the highway, a lorry, as I guess you might say, where you live. As you're passing it on the highway, it seems to slip backwards because you're moving faster. Same thing, Neptune tonight is moving in the wrong direction because Earth is passing it. We're lined up. Sun, Earth, Neptune. That's why we call it opposition, because the sun is opposite in the sky to Neptune. Just as the sun set over the Canary Islands, that's when we saw Neptune rising on the opposite part of the sky. Interesting that opposition or lineup also coincides with when Neptune is at its closest of the year. Biggest, closest, brightest. So no wonder we're focusing on it tonight. And, I hope our Slooh members have, if they didn't know about Neptune, if they were not Neptune files beforehand, I hope they've seen that this is not just some minor object that you can shrug off. This is a fascinating and still mysterious body, major body. We're talking about the one of the 4 big objects in the solar system after the sun.
Well, it's a great point to end on. We're coming to the end of our live show here. We hope you've enjoyed these live pictures from the Canary Islands, where you've brought you those pictures of not just Neptune, but Triton, that enigmatic moon that hopefully in the coming decades we'll learn more about. As for me and Bob, well, that's about all from us. Of course, it's not all from Slooh. We've got a fantastic selection of shows coming up over the next few weeks. We've got that Nightlight program that's coming every other night. And of course, we've got that fantastic partial solar eclipse show on September the 12th, on the night of Saturday, September the 12th. So do join us for that. Then, of course, that International Space Station show, Mankind in Space, where we're going to be speaking to a NASA astronaut, Katie Coleman, and also hoping to bring you not just live views of the ISS from Earth, but live views of Earth from the ISS as well. And then on September the 23rd, we're going to be celebrating the autumnal equinox, 24 hours of sunlight, where we basically look at not just the astronomy and the science behind what's happening at the equinox, but also what it's meant to us humans throughout history, what impact it's had on our culture. And then, of course, we finish with the mega harvest moon eclipse on September the 28th. You will not want to miss this show. A fantastic event where the moon passes into the Earth's shadow and goes that extraordinary red color, total lunar eclipse. So don't miss that show. For now, though, from me and Bob, we'll leave you with this beautiful live picture coming in from our observatory in the Canary Islands of Neptune and Triton. We hope you've enjoyed looking at these views and listening to us talk about this fantastic planet. And we hope to see you next time on Slooh.com. Good night.
This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit Slooh.com to become a member today.
That's where Neptune is, and actually you can see in the left-hand corner there, Slooh's telescopes, the domes are open, and we are, as we speak, capturing images to bring you live pictures of Neptune tonight. Now, of course, as I said, opposition is a great time to look at Neptune and observe Neptune, but it's also a good time to sort of take stock, and I think in some ways it's a good time to reflect on what we know about this enigmatic planet and also what we don't know, the sort of mysteries of the planet, because in many ways there's a lot that we want to find out about Neptune. Neptune is a planet that we've visited only really very briefly, and we're going to be talking lots in more detail about some of its other more mysterious side, like some of its moons. The moon just with the naked eye of a beautiful horizon. We have to use binoculars or a telescope to see it. And tonight, of course, here on Slooh.com, we're going to be using our powerful telescopes located tonight in the Canary Islands, the ones we're using. So as this zooms into La Palma and Tenerife and Lanzarote and all the Canary Islands there, we'll see as we come into the top, we see our Slooh Observatory there on the hillside. And we've got fantastic conditions tonight. We already know that the skies are clear over Mount Teide in the Canary Islands, and we've got a beautiful view of the heavens tonight. Now, the moon is up, so if we can go to our live all-sky image, you'll see that bright object there, that's the moon in the sky, but off to the right of it, you can see Hello and welcome back to Slooh.com. My name's Will Gator, and tonight we're celebrating the opposition of the gas giant, the ice giant Neptune. What does that mean? Well, tonight the planet is opposite, directly opposite the sun in the night sky. And it's a fantastic time to look at the planet because it is visible all night long as it sits there in the sky. Now, unfortunately, we can't see this planet with the naked eye. It's not like those beautiful, sparkling planets, things like Venus, Jupiter, and Saturn, which we can admire